Improving irrigation management in vegetable and agronomic crop production reduces production costs, saves water, and reduces the risk of nutrient leaching. Water movement in the root zone below crop roots is difficult to see. Injecting soluble dye through the drip irrigation system provides a simple and practical method of visualizing water movement in the soil. Understanding water movement in raised beds is essential for improving irrigation scheduling and nutrient delivery. Dye tests are practical tools to determine how much water can be held in the root zone by showing how deep and how wide water moves in raised beds as irrigation volumes increase. This information is then used to determine how to split irrigation events and better manage water and nutrients. Besides irrigation volume, several other factors affect water movement in raised beds. These include soil texture, soil organic matter content, bed compaction and/or width, soil depth, and the presence of an impermeable layer. It is important to conduct a dye test under conditions similar to actual production conditions so that water movement observed after the dye test are representative of those occurring during crop production. Dye may be injected with an irrigation pump or Venturi injector shown in these photos. The injection pump in this photo is a hydraulic pump that uses the pressure of the irrigation water to move the dye from the bucket into the irrigation system. This system uses the same type of injection pump to move dye from the bucket into polytubing for a few drip lines in the field. The dye test assumes that the dye moves through the soil with irrigation water front. Dye selected should be totally soluble and not absorbed by soil particles or soil organic matter. Once the system is operating, inject the dye and block drip tapes at a predetermined time to give a range of irrigation application times. The shortest irrigation time will be located away from the water source, and increasingly longer irrigation times will be close to the water source. Pressure monitoring during the dye test is important, especially each time a section is turned off. As time progresses, the length of the remaining drip tape is shortened in the irrigation system, which may result in increased pressure and water flow. Pressure and water flow should be kept as constant as possible during the entire test to ensure that operating conditions match those recommended by the manufacturer. After the dye test, sections of soil should be carefully dug from each drip tape and each operating time. Each dye pattern will appear as a blue ring below each emitter. The dye pattern may appear faded immediately after digging. However, the contrast between the colored area and the remaining soil will improve as the bed dries out. When dye is injected during the entire test, all the wetted area is colored in blue. Observe the shape of the wetted zone. Is it round or elongated? The more sand in your soil, the more elongated the shape will be, and more than one drip line may be needed to wet the entire bed width. Did the dye move outside of the bed? Sandy soils typically do not allow the pattern to extend to the edge of the beds unless they are very narrow. When did the dye pass below the root zone? When did the dye reach the impermeable layer? The time required to reach the bottom of the root zone and not reach the impermeable layer will be the time required to properly irrigate your crop and not over-irrigate, potentially leaching your fertilizer nutrients. When did emitter-to-emitter coverage occur? If the wetted patterns are too elongated, narrow emitter spacings may be required to wet the entire length of the raised. What is the size and shape of the wetted zone under typical irrigation times? Important wetting characteristics are maximum wetted width, shortest time or volume needed for emitter-to-emitter coverage, and time or volume when irrigation reaches the bottom of the root zone. Each irrigation event has to be a compromise between providing moisture to the crop and minimizing off-site water and nutrient movement.